All right, this is 8.04, day 2. And today it's going to be verifying identities. So last class we did identities where you were just simplifying them and there was no equal sign. Or today you're going to see you're verifying them. So you're trying to show that the left-hand side is equal or the same as the right-hand side. So here are some hints that might be helpful for you to look for as you do these types of problems. So you want to look for opportunities to use the fundamental identities. So if there are squared trig functions, a good idea is to try your Pythagorean identities. So like your sine squared plus cosine squared equals 1, identities. If the functions are not squared, try converting to sine and cosine. So like we did last class, get everything in terms of sine and cosine. Again, always try something. And it doesn't matter which side you start on. So I'm going to write this out. It doesn't matter which side you start with. Which side you start with. But, and this is really important, you may not work on both sides simultaneously, meaning at the same time. So you can't add over something or subtract something from one side to the other. So you can only work with one side at a time. Only one side at a time. So you're trying to get one side to look the same as the other side. And always try something. So don't just look at it and say, I don't know what to do. Try to use your Pythagorean identities. Try to convert to sine and cosine. Those are the two main things that you want to be looking for. And let's box this up. And let's try some. So, number 1. So verify the identity. Cosine squared x plus cosine squared x times tangent squared x equals 1. So this one, you don't have as many options here of which side you want to start on because one side is just a 1. So we cannot add or subtract anything over between the two sides. So that's why I draw a line here. You can only work with one side at a time. So the 1, there's really nothing I can do there. So I'm going to look at my left-hand side. So I do see squared functions, but I don't see anything yet to do Pythagorean identity on. If I needed to, I could put 1 minus sine squared in here for cosine squared. But before I do that, I'm going to try and do get everything in terms of sine and cosine. Again, there's more than one ways of doing these. Sometimes the way you choose might be shorter or longer than another way. So here I've got tangent squared. That's not in terms of sine and cosine, but I do know that tangent is equal to sine over cosine. So tangent squared is equal to sine squared x over cosine squared x. And since that's a fraction, I'm going to put this over 1. All right, so now I have multiplication right here. And I see that I have a cosine squared down here and a cosine squared up here. So I can cross reduce those because it's multiplication. I can't do anything with this over here because that's being added to those. So now if those cancel, I'm left with just cosine squared x plus sine squared x. Wait a minute. I know sine squared plus cosine squared gives me 1. And what do I have on the other side of the equal sign? I don't want to put it over there. Equals 1. So 1 equals 1. Once you get the left-hand side, you don't have to write this equal sign here. Once you get the left-hand side equal to the right-hand side, then you're done. You've proven that identity or verified that identity to be true because the left-hand side is equal to your right-hand side. Let's try another one. So again, verify the identity. This one is cosine x plus cotangent of x over 1 plus cosecant of x equals cosine x. All right, so again, you cannot add or subtract, multiply or divide the equations by anything. You just need to work with one side at a time, get it equal to the other side. So the right-hand side is cosine of x. Again, this one, not a whole lot I can do on that side, so I'm not going to really worry about that. I'm going to try to get the left-hand side to equal cosine of x. This time I don't see anything squared. So now I'm going to just try to rewrite everything in terms of sine and cosine. Pause your video, rewrite all of this in terms of sine and cosine. Remember, I'm saying sine and cosine, not tangent. So make sure it's sine and cosine. All right, so cosine of x plus cotangent. So I don't want you to write it as 1 over tangent because I want to try to get everything in terms of sine and cosine. So cotangent, that's my coco. So cosine x on top over sine of x divided by 1 plus cosecant is the same as 1 over sine of x. And I'm going to put this over 1 and this over 1 because everything's written as, the other two are fractions. All right, so from here, again, I've gotten everything in terms of sine and cosine. So that's something everybody can do as long as you have your reciprocal trig functions memorized and you know tangents, sine over cosine, cotangent is cosine over sine. Now I have fractions inside of a fraction. So I have a complex fraction. What do we do when we have a complex fraction? Well, hopefully you're thinking, you look at your denominators of all 4 fractions. I have 1 sine x, so my LCD would just be 1 times sine x, which is sine x. Now to get rid of my fractions, I need to multiply every fraction by my LCD over 1 for complex fractions. So sine x over 1, sine of x over 1, and even this 1 over here should get a sine x over 1, and this as well. So this is the same thing we did with our complex fractions now. Pause the video and see if you can continue on your own. All right, so here, nothing to cross reduce. Here I can cancel out the signs. Here are the signs and nothing over here. So everything in my denominator is either a 1 or canceled out. 1 canceled, 1, 1. So now I'm going to rewrite it as just one fraction. So I have sine x times cosine of x plus everything canceled here except for cosine of x. Here I just have sine x and everything canceled out here. So that means I have a 1. Make sure you don't make it disappear. You should still have a 1. All right, next. I now have, go over here, looking at my numerator, I have a GCF of cosine of x. So cosine of x is my GCF. So I'm going to factor out that cosine of x. So if I take out a cosine of x, I'm dividing each of these by cosine of x. If I divide sine x cosine x by cosine of x, I'd be left with just sine of x. And cosine of x divided by cosine of x would leave me with 1 over sine x plus 1. Ooh, now this is looking good. Now I've got sine x plus 1 on the top and a sine x plus 1 on the bottom, leaving me with just cosine of x. And on the other side of the equation, we had cosine of x. So now I got the left-hand side to equal the right-hand side. So those are equal to each other. Okay, let's try another one. Verify tangent of x plus cotangent of x equals secant of x times cosecant of x. All right, so here, draw your line. This time, again, we can go left or right side, and this time there's something you can do on both sides, so it really doesn't matter. You could even do a little bit on each side, as long as in the end you get both sides to be the same thing. So let's start with the left-hand side. So here, again, a lot of students tempted to write 1 over tangent for your cotangent. I want to try to rewrite everything in terms of sine and cosine. So for tangent, I'm going to rewrite that as sine of x over cosine of x. And cotangent is cosine of x over sine of x. Now I want to add my fractions. In order to add fractions, I need a common denominator. And these do not have a common denominator. So what would my LCD be here? And we would have to include both the cosine and the sine of x. Whenever you don't have an equal sign, it's need over need. So here, what do I need in order to get this denominator? I need a sine. So I'm going to multiply the top and the bottom by sine of x. Over here, this one needs a cosine, so I multiply by what it needs over what it needs. Okay, pause your video and see if you can combine these fractions into one. So I have sine times sine gives me sine squared x over sine x times cosine x, plus cosine times cosine gives me cosine squared x over sine x times cosine x. Now I have a common denominator. They both have a denominator of sine x, cosine x, so I can combine them into one fraction. So I'm going to add my numerators, sine squared x plus cosine squared x, and keep my denominator of sine x, cosine x. Oh, I love when I see that sine squared plus cosine squared, because I know that's my Pythagorean identity, and it's equal to 1. So again, I don't really know what's going to happen with this. I'm just taking it step by step and just simplifying it as much as I can. So maybe I stop there because I say, okay, well, I've got 1 over sine x, cosine x. Let's go back up and look at the right-hand side. You could have continued on the left-hand side and rewrote this as 1 over sine times 1 over cosine, but maybe you weren't sure what to do. So maybe you go back up here and say, okay, well, I know secant of x is 1 over cosine, and I know cosecant is 1 over sine of x. Now I have something that's really close to what I have there. I just need to multiply straight across the top and straight across the bottom. And now I have 1 over sine x times cosine x on both sides. And I just, if you want to switch it, they're using your commutative property, and then it looks exactly the same. So you've got 1 over sine x, cosine x on both sides. But again, our papers might not always look the same. Somebody could have separated this over here and done 1 over sine of x times 1 over cosine of x, and maybe that's where they stopped on both sides. Or maybe they took this further and rewrote this as cosecant of x times sine of times secant of x. So there's a lot of different endings for this. What the main goal here, though, is to get them to be the same. Get the left-hand side to be the same as the right-hand side. All right. And number 4. Verify again. So sine squared x plus cosine squared x equals sine x times cosecant x. Pause your video. I want you guys to do this one on your own. So try to get the left-hand side equal to the right-hand side. This one should be a little bit shorter. Okay, so hopefully you saw here sine x plus cosine squared. We know that's 1. Okay, over here I have sine x times cosecant of x, which I know is 1 over sine of x. Put that over 1, can cross reduce, and I get 1. So I have 1 on both sides. So I have verified my identity for that one. All right, now let's look at one with a little bit of algebra in it. So this is number 5. So one identity that we know is our difference of two perfect squares. So we know that if I take x squared minus y squared, that's equal to x minus y times x plus y. So if we want to prove this, so first of all, you could test it with some numbers. So let's do that first. So test with x equals 10 and y equals 3. So go ahead and substitute in 10 in for all your x's, 3 in for all your y's, and see if you get a true statement. Go ahead and pause the video, do that right now. All right, so you would have had over here 10 squared minus 3 squared, here 10 minus 3 times 10 minus 3, and then you'd have 100 minus 9. We're seeing, are these equal? 10 minus 3 is 7, 10, oops, missed an addition sign, 10 plus 3 is 13. 100 minus 9 would give us 91, 7 times 13 gives us 91. So if we test it, it works. Now I want to prove it. So for part B, prove this identity and to do that, we're going to do the same thing, except this time we don't have trig functions in it. You can't go from one side to the other. You have to just work with one side at a time. Okay, so over here, since we're proving it, you need to do the right-hand side over here. So we're going to try to FOIL this. We can't just factor it because that's what we're trying to prove on the left-hand side. So you want to go to the right-hand side and FOIL that out. So take a moment, pause your video, and FOIL it out. So we get x times x is x squared plus xy minus xy minus y squared. Our middle terms cancel out, and we're left with x squared minus y squared. So we have that on both sides. So we have proven or verified that identity. And we'll do one more. So that was 5. Number 6. So I'm going to give you a right triangle. And the side lengths are 2x, x squared minus 1, and x squared plus 1. So I want you to show that these will be the side lengths of a right triangle as long as x is greater than 1. Show or verify that you've got your Pythagorean theorem. So 2x squared plus x squared minus 1, so the 2 legs squared, equals your hypotenuse squared. So that's your Pythagorean theorem. All right, so pause your video, make sure draw your line, and work on getting those, let's flip off the square here, work on getting those two sides to be the same. Okay, so a lot of foiling and combining like terms here. Go ahead and work on that. All right, so here we've got 2 squared is 4, x squared is x squared, so make sure you square both the 2 and the x squared, plus here I'm going to write this one out twice because I'm squaring a binomial. I'm just going to work with the left-hand side for a little bit first. So now I have 4x squared, and I'm going to FOIL this out. So I've got x squared times x squared is x to the 4th, minus x squared plus 1. Now I'm going to combine my like terms. So I've got a 4x squared minus x squared minus x squared. So that's going to give me a 2x squared. I don't have any other x to the 4th, so I'm going to bring that down. So 4 minus 1 is 3, 3 minus 1 is 2, so positive 2x squared plus 1. And I feel like I can't really go too much further right now, so I'm going to hop over to the right-hand side. Just like with the others, though, you can't add or subtract anything from one side to the other, can't multiply the entire equation by anything. All right, so I'm squaring this binomial, so I wrote it out twice. And now if you haven't done this on your own already, pause the video, do it on your own. So we'd get x to the fourth plus x squared plus 1. And then if you combine your like terms, x squared plus x squared is 2x squared. And oh my goodness, that's exactly the same thing as we have on the left-hand side. So verifying showing identities are equal. You're just getting the left-hand side to equal the right-hand side without going between the two sides. And it doesn't matter what point you stop at as long as they're exactly the same on both sides. All right, and that is it for 8.04. If you have any questions, of course, let me know, and pie out.